Good afternoon.
Good afternoon.
Well, we timed that just right for the bell at some school somewhere. Okay, so let's see. Looks like everyone is there, so glad to see you all here.
I have a doctor's appointment, so I'm going to have to leave in about 5 minutes, though.
Okay, all right. All right, well, let's see if we can get a little bit done in 5 minutes. First of all, though, so Skylar or Chloe, somebody, you guys said something yesterday about that you thought that Skylar had a higher overall grade last semester. Anyway, and so it got me intrigued. Anyway, so I looked it up, and this is kind of embarrassing, but as I checked really quick the other day just to see what your overall grades were that I submitted, that while both of you had great grades and I was extremely proud of you, it turns out that neither one of you were the highest grade. So I apologize for announcing that incorrectly. Is that actually the highest grade from last semester was Aiden. So let's give it up to Aiden, for Aiden. So good job, Aiden. Anyway, but like I said, I was really proud of this whole class, and you guys did a great job. Like I said, I didn't have anything but A's and B's, and I've never had that in a calculus class as long as I've taught. So that's a great thing. So, and anyway, in some schools actually, I don't know about you guys, but some schools actually do give a weighted grade for a college class like calculus. So if you're concerned about your class rankings or whatever, you might check with your counselor. I know at Mogollon High School a few years ago, one of my students actually petitioned to have it weighted, and so I don't know if it became a permanent thing there at Mogollon or not, but I know it helped him at least be the co-valedictorian, so on. But anyway, the way that would work is the schools that weight it is like a B in calculus would be considered like an A in any other class. And if you got an A in calculus, then that would average in as a 5.0 into your GPA. And so that would really help, I'm sure. So anyway, I wish I could make that a policy everywhere. But like I said, I know Mogollon did it at least one year. I don't know if they still do. Do you guys know? Do they still weight the grade?
I think we still do.
Yeah.
So they have like
Okay.
a 4 point something.
So you get a little bump anyway. I know Joseph City was talking about it. I know Holbrook does it. And who else does it? Anyway, do you guys at St. John's or Winslow know? Do you get any kind of bump in your grade?
I'm pretty sure it's weighted here.
Yeah. How about Winslow?
I think it just depends on like the quarter grade and the semester grade or something.
Okay. Well, anyway, I hope it helps you anyway. Okay. Well, so today let's talk about what we're trying to do. So today we're going to try to finish 7.5. We just got a little bit yet to do, and then start in on 7.6. So any questions before we get going? Okay. Oh, go ahead.
I didn't have enough time to finish my second attempt at 7.4, so if you can open that up for me after class today, that would be great.
Okay. All right. We'll do it. So all right. I will do that. Okay. Well, let's go ahead and get moving here. All right. So we had kind of finished up with this practice problem. And so this one, when you plug in 0, you end up with infinity minus infinity. And so that's also considered an indeterminate form. Okay? So that's, whether it's infinity minus infinity, or see, negative infinity plus infinity, that's the same thing if you reordered it. It's still going to be an indeterminate form. All right, so then what you want to do is combine the fractions. All right, so what's the least common denominator of x and x squared?
X squared.
X squared. So all you have to do to get a common denominator is multiply the first fraction by x over x. Whoops, okay. What are we doing here? Oh, all that's just to, I think somebody wanted to make sure that it was indeterminate. Okay. So where did the problem go? Oh, here it is. So if you multiply top and bottom by x over x, then you get x over x squared. So x minus 1 over x squared. And then you plug in 0 again, and you get a constant over 0. But since the constant is negative, so it will be negative infinity. Any constant over 0 is going to give you infinity over negative infinity. You just then have to kind of verify which it is. And so in this case, 0 minus 1 is negative over 0, so that will be negative infinity. Okay? So any questions about that? Oh, I'm not showing up here. Okay. All right. So any questions on this? Okay. So just a little algebra on that. All right, now this one is kind of an interesting type, and this is when you're trying to take the limit, and you have like a function in your exponent. Then what you want to do is actually take the natural log. And I mean, go ahead and write this down, but this formula here or whatever, unlike most formulas, this doesn't really help you know what to do. Okay, so this is a lousy formula in my opinion. I mean, I'm going to use it, but basically what we're going to do is we're going to use natural logs to do a limit when we have a tricky exponent. Okay? So let me show you an example. It'll make it more clear. Okay? All right, so here we have an exponent of 1 over x. And so that's kind of tough to deal with because when we plug in, you end up with 1 raised to the infinity power. Okay, let's see. What is this? Okay, so we have 1 to the infinity power. Now, okay, so going back to let me sidetrack here for a second. Okay, so at the beginning of the lesson, wait, sorry, I went the wrong way. Okay, here we go. All right, so at the beginning of the lesson, I showed 4 indeterminate forms. There's actually a 5th that we're going to add now to this list, and it is 1 to the infinity power. Now, you might say, wait a second. 1 to any power should be 1, right? But see, remember, we're doing limits. And so as the value approaches 1, see if it's like 0.99999, if you raise a number less than 1 to a positive power, what's going to happen to the number?
It's going to start getting smaller.
Yes, and it'll approach 0, in fact. So then if we raise a number slightly bigger than 1, so like 1.1, and you raise that and keep multiplying it by itself, what'll happen to that?
It'll approach infinity.
Right. And so since we're talking about limits, this becomes an indeterminate form. Okay? Because of that. So now let's go back to our problem. Okay, here we go. So what we do is you just sort of, so here we plug in 0, so we get 1 to the infinity, and that's an indeterminate form. All right? So now what we're going to do is take the natural log of both sides. Okay, now why are we doing that? Well, here's just a general trick, is algebraically, when you have a tricky exponent and the exponent is messing you up, try working something with natural logs, okay? Because if by working with logs, it allows you to bring that exponent down, okay? So see, I've taken the log of both sides here, okay? Well, no, all right. All right, so now, as I focus on this, because this is a log, I'm allowed to bring the exponent in front. So 1 over x, or the natural log of this over x. Okay. And now I really can't simplify that, so let's plug in 0 again, and I get the natural log of 1, which is 0, over 0, so that's an indeterminate form. But see, now I have a fraction. So now I can apply L'Hopital's rule. So, what's the derivative of the natural log of 1 plus x? What's the derivative of the natural log of anything? So the derivative of natural log of u is 1 over u times the derivative of u. So for this, the derivative of the natural log of 1 plus x is 1 over 1 plus x times the derivative of x, which is just 1. Okay? So we get 1 over 1 plus x, and now the derivative of the denominator is just 1. So I could kind of ignore that, so it's just going to be 1 over 1 plus x. So as I plug in 0 now, I get 1 over 1, which is 1. Okay? But that's not the final answer. Because, remember, I took the natural log of both sides. So I have to sort of undo that. And so what we do to undo it is you exponentiate both sides. So your answer is going to be e to that final answer, e to the first, or just e. Okay? So this is the answer. Let me just kind of go through that logic again. So I have the f of x equals the limit. So I took the natural log of both sides. And then over here I worked it out and I got 1. So then to get rid of that natural log, as I rewrite it as an exponent, natural log is log base e. So this would be e to the first power equals f of x. So the limit is actually e to the first or e. So when you take the natural log of both sides and then calculate the limit, then the final answer is going to be e to that number. Okay? All right, let's see if you can apply that to that last practice problem there on, so practice 7. All right, so Jordan, what do you have? Jordan, do you have it? What? Oh.
So I got to the point log natural 1 over x, but I can't figure it out past then.
Okay, all right.
Still working on it.
So, okay, so you got this far?
A little bit farther. I got to the where we used L'Hopital's rule, and unless
So then, okay, so then you end up with 1 over x? Yes?
no, I left the log natural in there.
No,
So-
okay, so the derivative of natural log of x is just 1 over x. And then the derivative of x is just 1. So then when you plug in infinity, 1 over infinity goes to 0. Okay? But that's not the final answer. So what's the final answer?
E to the 0 power or 1?
Yes, that's it. Okay. All right. Any questions on that? Yeah, so for this next test, you got to make sure you know how to take the derivative of natural log of x, because that's going to pop up in a bunch of questions. Okay? All right, well, that's it for 7.5. Okay? All right, so let's go on to 7.6. All right, so 7.6 is on inverse trig functions. Now, the first part probably, I don't know, most of what we do today in this is going to just be a review of trig, of the inverse trig functions in trigonometry. And maybe we'll get to a little calculus in this section. I'm not quite sure, but anyway. But the first part, the first column on your paper is just a review. Okay, so when we're talking about inverse functions, remember that to determine if the graph is a function, you do the vertical line test, and if a vertical line hits it more than once, then it's not a function. So like here, the sine, for example, is a function. But then to determine if its inverse is a function, you do the horizontal line test. And so here a horizontal line hits it more than once. So you'd think then that the inverse sine function would not be a function. So what we do then to make it so that it is a function is we actually restrict the domain. We sort of cut it off and say, okay, we're only going to go from here to here, from 0 to 2 pi. And then if we do that, then see what happens is then we can make it past the horizontal line test. So if we're only going to apply, say, this part, okay, if we're only going to use this part and nothing else, then it does pass the horizontal line test. So by restricting the domain, we make it so that the inverse has a function. Okay, so the inverse is a function, I should say. Okay, so where do we cut it? Well, for inverse sine, we just use the part of the sine function from negative pi halves to pi halves. So actually we use so from negative pi halves to pi halves. So that would be quadrant 1 and 4 for the inverse sine. For the inverse cosine, we use quadrants 1 and 2. Inverse tangent 1 and 4, inverse cotangent 1 and 2. Now, I used to get that mixed up until I saw this graph right here, this little chart. And I don't know why, but everything clicked for me when I saw that. So you might want to write that down, and I always show that to my trig students, so you might remember that. So here's inverse sine. This is showing what quadrants the angles will come out of. So for inverse sine, it's quadrants 1 and 4 and inverse tangent. And then for inverse cosine and cotangent, it's quadrants 1 and 2. Okay. Okay, now as far as the graphs, you can see I sort of ignored the graphs of the inverse trig functions with one exception. The inverse trig function that you need to know is the inverse tangent. Okay, so this graph goes from negative pi halves to pi halves. And so quite often this pops up in random problems where we'll need to know the limit as x approaches infinity of the inverse tangent. Now, so just looking at the graph, what would the answer be from the graph? What's the limit of this function as x approaches infinity?
Pi halves.
Pi halves.
Pi halves. Okay. So so that's an answer you would need to know. Or the limit as x approaches negative infinity would be negative pi halves, because the graph lives between those two, from negative pi halves to pi halves. Okay. So now, again, you could put that in your calculator or whatever, but that graph is helpful to know. All right. Now, when the idea of the inverse trig function, you might remember from trig, is that what it does, it gives you the angle. So the inverse sine gives you the angle in quadrant 1 and 4 that has the given sine. The inverse cosine gives you the angle in quadrants 1 or 2 that has the given cosine. So just remember that that's what the inverse trig function does for you, is it gives you the angle. Okay? Now, in a calculus problem, usually the angle that we want is going to be measured in radians. But in the real world, typically angles are measured in degrees. So in more application problems, we'll want the angle in degrees. And so we'll talk about that a little bit. Okay, now, instead of, this is just a little history, you don't have to know this per se, but this notation you do need to know. The notation of inverse sine basically is saying it's the inverse function, and it gives you the angle. It used to be known as the arc sine. They actually mean the same thing. And matter of fact, when I was in high school, instead of like having this button, like where you press second and whatever, instead of the inverse trig functions, it had arc. Okay? Because the way trigonometry was taught was much different back in the day, because it was mostly all with a circle. So instead of SOHCAHTOA and how we begin trig these days, it was always taught with the circle, and the central angle of a circle is the same as the angle of the intercepted arc. And so to say this angle has a sine, if this angle has a sine of blah, 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 it would be the same thing as saying the arc has a sine of blah, 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 or cosine of whatever. And so, but nowadays, even in trig, we don't really use arcs to explain angles. And so the whole notation of arc sine or whatever has sort of lost a little bit of its meaning to students. But it's still out there. You still need to know it. Okay? But we don't really teach it like this. Okay. So the expectation is that you know your unit circle. So if you don't know your unit circle, go back into your notes from 1.3 in Calc 1, and hopefully you've got the unit circle written down or whatever, or you've got it memorized. But the arc, the inverse trig functions give you the angle. So if I say I want the arc sine of 1/2, then remember the sine is the y value. So this is saying if the y value is 1/2, give me the angle. And so the answer would be pi 6. Or if I say the arc cosine of 0. So the cosine is the x value. You look and you say, okay, the x value up here is 0. So the angle is pi halves. So again, the answer is the angle when we're doing the inverse trig functions, okay? Any questions on that? All right. So let's see, all right, so let's go ahead and do on the notes, y equals the inverse sine of x is the number in. So you can either put the quadrants there or the interval, which is easier for you. So you can say quadrant 1 and 4, -90 to +90, or negative pi halves to pi halves. And then y equals inverse cosine of x is the number in. You could put quadrants 1 or 2, 0 to 180, or 0 to pi. Okay. All right. So go ahead and do practice 1. All 4 of those. All right, so Jordan, what do you have for the first one? Let's make sure we're all on the right track here.
So question, do you want like an answer in like degrees or
Yeah, let's do the answers in degrees. No, I mean in radians. Let's do them in radians. Sorry.
I got 30 degrees and then for radians 0.523.
Okay, so I want the exact answer in radians. So 30 degrees is how many radians?
Pi divided by 6.
Right. Okay. Now, one easy way to remember that, so you don't have to look it up, is if you say, okay, so pi radians is how many degrees? Anybody remember that?
180.
180. So then pi 6, think what's, let's see. No. So you have 30 degrees. So if you say 180 divided by 30, or 30 will go into 180 6 times, so it's pi 6. So it's 1/6 of the way. I don't know if that helps. But anyway, for some reason, my brain, it helps. For me to know that 3 will go into 18 6 times, so it's pi 6. All right, so Aiden, what about the second one? What would be the angle whose sine is negative radical 3/2?
I got 4 pi thirds or 5 pi thirds.
Okay, now it's not going to be both, because the inverse sine, we want the answer to be in quadrant 1 or 4. So we don't want anything in quadrant 2 or 3. So 4 pi thirds,
Okay.
toss that answer.
So it would be 5 pi thirds.
So it'd be 5 pi thirds. Okay? Okay? Now, 5 pi thirds, do you understand that that's the same coterminal angle as negative pi thirds? Right? Because if I took negative pi thirds and just added 2 pi to it, I would get the same thing. So negative pi thirds, if you measure down, if you measure all the way around, that would be 5 pi thirds. So it's the same coterminal angle. Okay. All right. Let's try the next one. All right, Skylar, how about C?
Pi thirds.
Pi thirds. Okay, everybody cool with that? And the last one, Skylar again.
5 pi over 6.
5 pi over 6. So 5 pi over 6, that's in quadrant 2. So that's kind of where you need to know that, is that, so inverse cosine, your answer has to be in quadrants 1 or 2. Inverse sine, your answer has to be in quadrant 1 or 4. Okay? All right, so great job, Skylar. Any questions on that? All right, so course correction. The angle required to make a course correction is found by inverse trig. Okay, so what we're going to do is set up a problem where you need inverse trigonometry to find a course correction angle. So how far off you are. All right, so let's look at this example. It says, after hiking 5 miles through the desert on a straight line, you realize from a landmark that you are 0.5 miles off course. What is your navigational error in degrees? So again, now, so Jordan, where you were asking about the units. So again, in kind of the real world, like a compass heading, they don't give compass headings in radians. So it's in degrees. So the first thing I would do is try to draw the triangle and say, okay, so you've walked along a straight line for 5 miles, but see, you should have been this way, but you're 0.5 miles off course. So then to figure out that angle, then what you do is you say, okay, what trig function relates these two sides of the triangle? So you know in relation to the angle, how far off course you are, or the angle you're off course, that this is the opposite side, this is the hypotenuse. So then you say, well, what trig function is going to relate those? And it's the sine. So you say the sine of theta is opposite over hypotenuse, so 0.5 over 5, which simplifies to 0.1. So then to solve for theta, then you take the inverse sine of both sides. And so then that gives you theta equals the inverse sine of 0.1. And so now when you put that in your calculator, this is very important, you guys. When you do the inverse sine in your calculator and you want the angle in degrees, you got to be in degree mode. So check the mode in your calculator before you ever type in inverse sine, or any trig function for that matter, and then it would give you the angle in degrees. Okay? All right, any questions on that? All right, so go ahead and try practice 2. All right, so Jordan, when you've got it.
I got 1 degree off.
1 degree off. That is correct.
And question, is this based off of the story of that one plane that was flying to Antarctica and crashed into
You
the mountains?
have a great memory, Jordan. You even remember my crazy stories from a year ago. Okay? Yeah, it is, in fact. Because when I was making up this example, I had just taught that in my trig class. And I'm like, oh, I'm going to do that plane story. So those of you that don't remember, or that there was this commercial airline in Australia that wanted to start doing flyover tours of Antarctica, because like in the 50s, nobody knew what Antarctica was about. And there was, some people thought, there were no satellites in those days, right? So some people thought maybe there's still dinosaurs there or a lost civilization. Nobody really knew. And so they were very popular tours. And so, but one time, one plane, all full of its passengers, didn't come home. They didn't return. And so they sent a second plane out to find them. And they found that they had crashed into the side of a mountain and killed everybody. And so then when they recovered the black box that, records everything, and they realized, and then from other information they found that the navigator had made a 1 degree error in his calculations. And so then when it got all foggy and they were flying by instruments, they thought they were flying over, a level ice tundra, and they ended up flying right into a mountain. So it's kind of a sad story, but the moral is check your math, right? So anyway, I'm so, you have no idea how happy I am that you would remember that story. So anyway, so any questions on this? Okay, let's see. Okay, let's do. All right, so let's see. Then we've got common values for the inverse tangent and the inverse cotangent. So the inverse tangent is the number in, and again, I just think quadrants 1 and 4 for the inverse tangent and 1 and 2 for the cotangent. But you can also put the intervals in there too, from 0 to pi or negative pi halves to pi halves, whichever you prefer. All right, so when you're using the unit circle, tangent and cotangent are a little bit tricky because they're not directly on there. So like if I wanted the inverse tangent of -1, well, so that would actually be down here at 7 pi fourths or negative pi fourths, because the y over the x and the y are the same thing, but one of them has a negative sign. So when you simplify that fraction, it would be -1. Or like say, let's say I wanted the inverse tangent of 0. Then see, it's the y over the x, so 0 over 1. So the answer would be 0 radians. Or if I want the inverse tangent where it's undefined, well, where the tangent is undefined is up here at pi halves, or 90 degrees. Okay? All right, so see if you can do practice 3, both of those parts there. And we'll quit with those. Which is perfect because the next part starts with the calculus in part 4. All right, so Aiden, what's the inverse tangent of 1?
The pi fourths.
Pi fourths. Very good. You might also remember that from your 45, 45, 90 triangle. Okay. Okay, and Aiden, you get the last one too.
11 pi sixths.
All right, so yeah, and now that's the same. See, normally we say that from negative pi halves to pi halves. So that's why I'm just kind of expressing your answer in a different way, but your answer is correct. Okay, but negative pi sixth is the same thing as 11 pi sixths, just adding 2 pi to it. All right. Okay, so that's it. We'll pick it up from there tomorrow. You guys have a great day, and David, you're all set for your quiz, and we'll see you tomorrow.